What is the relationship between cosmology and inflation theory? Imagine trying to understand how the universe came to be and how it grew so vast and uniform. That's where cosmology steps in. It's the science that studies the universe's origin, its structure, how it changes over time, and what its future might hold. Now, within this big picture, there's a special idea called inflation theory. It's like a story about a super fast growth spurt right after the universe was born. Inflation theory was created to solve some big puzzles that the traditional Big Bang model couldn't fully explain. One of these puzzles is the flatness problem. Think of the universe as a sheet of paper. Why does it look so flat and not curved like a ball or a saddle? Inflation suggests that a tiny, curved universe could have stretched out to look flat because of a rapid expansion. Another puzzle is the horizon problem. Imagine two parts of the universe that are so far apart they could never have exchanged signals or energy. Yet, they have almost the same temperature and properties. Inflation theory says that in the very early moments, these regions were close enough to interact before expanding rapidly. This explains their similar features today. The monopole problem is about magnetic monopoles, tiny magnetic particles predicted by some theories. Scientists haven't found any, even though they should be common if the universe didn't expand quickly. Inflation would have diluted these particles, making them extremely rare or indetectable now. Inflation happened in a tiny fraction of a second, roughly between 10 to the minus 41 and 10 to the minus 35 seconds after the Big Bang. During this time, the universe grew exponentially, increasing in size by a factor of about 10 to the 26 or more. This rapid growth was driven by a mysterious energy field called the inflation field. When inflation ended, the energy from this field turned into matter and radiation, heating up the universe again. This process is called reheating and set the stage for the slower expansion we see today. Inflation also explains how the universe's large-scale structure formed. Tiny quantum fluctuations, or small density differences, got stretched out during inflation. These tiny variations became the seeds for galaxies, stars, and clusters. Without inflation, it would be hard to explain how such structures could have formed from a uniform beginning. So, the relationship between cosmology and inflation theory is very close. Cosmology provides the big questions about the universe's origin, and inflation offers a way to answer many of those questions. It connects the very small, like quantum physics, with the very large, like the universe itself. Understanding this link helps scientists piece together how everything started and evolved into the universe we see today.